So the next relationship that we are going to look at is between physical properties, is the relationship between mass and weight. Okay, so this is something that is commonly mixed up by people, the difference between what is mass and what is weight. So let's kind of think about both of these first. If we think about mass, so mass is basically mass is what you measure when you use a balance or a weighing scales. So mass is typically measured in grams or kilograms, and it's a quantity. Now there's smaller units as well, but typically you're measuring it in grams. So if I take an object, any object, like let's say this is a brick, okay, what gives the brick mass is matter. Okay, and if we think about like what are the properties of matter, so it has mass and it also has volume. And this mass quantity, basically what matter is made up of, it depends on what the brick is made of. But bricks, but everything, matter, is made up of what are called atoms. Okay, atoms. And if we remember, so the atoms basically you have in the nucleus you have, for example, protons. Then you have, like for example, you have neutrons. Okay, and they're inside the middle of the atom, which is the nucleus, and then around it then you have what are called electrons. And the mass basically comes from, and the mass basically, it comes from these subatomic particles here, which are protons and neutrons. So protons have a positive charge, neutrons they have no charge, and then electrons have a negative charge. Electrons are really small, so their mass is very, like it's almost, they almost don't really have any mass at all, electrons. But the mass of atoms comes from these subatomic particles in the nucleus of the atom called the proton and the neutron. And atoms then join together and they make like bigger objects. They essentially make up like bigger objects. Now it depends on what the brick is made out of. So you've different atoms are made up. What is it that distinguishes like one atom from another? It's these guys here, the number of protons that are present in the atoms. Okay, so that's what distinguishes one atom from another, is the number of protons. But together, protons and neutrons is what gives matter this property of mass. So when we talk about the mass of an object, for example, the mass of this brick, really what we're talking about is how many atoms are in that brick. And then really what we're talking about then is how many protons and neutrons collectively, with all the atoms that are joined together, make up this brick. Now just bear in mind, so this whole thing, like an atom for example, they are extremely small. So if you were to take this full stop here, and if you imagine like all the grains of sand on all the beaches on the entire planet, and that's roughly how many atoms would fit inside that full stop. So these atoms are extremely small. Okay, but what I'm trying to kind of get across is that mass, which is measured in grams, what we're actually measuring is how much matter is in an object, or another way to think about it is how much protons and neutrons are present in the atom. So that's where matter is coming from. When we talk about mass, that's what we're actually measuring. We're measuring the number of atoms in it. Now, when we talk about weight, So, so weight. Mass has this property that's associated with it. So if I take an object like a brick, okay, it has, because it has matter and because it has all of these atoms in it, it has this force that's associated with it, which is called gravity. And basically gravity is a force. So if we have two masses, let's say, so you have a brick here and you have another brick here, there is this like attractive force between these masses. Now it's extremely small between two bricks, okay? But the way to think about it is an object that has mass, it also has with it this force of gravity associated with it. Now what happens is the bigger the mass gets, this force of gravity grows with the mass as well. So if you really scale up and you think of something, let's say, like our planet, okay, so the planet Earth, because this is it's a huge object, okay, and it has loads of mass, so it has loads of matter. Like think about all of the atoms that, if one atom, so this can contain all the grains of sand worth of atoms on the planet in this size. Imagine how many atoms actually make up the whole planet. And then with that, because it has such a big mass, so it has a really big mass, it has a big source of gravity as well. And gravity is a force, and we measure gravity in newtons. We measure force in newtons. Now, because the Earth has such a big mass, as a result of that, it has a huge. So basically, it has a big force of gravity associated with it. So basically, what the Earth is doing, its force of gravity is pulling everything towards it. So as a result of that, because me and you are on the Earth, so you're probably sitting somewhere watching this, you're not just floating off into space. Why are you not floating off into space? Because the force of gravity pulls you towards the Earth. And so what you can think about is, you can think about, so you as a body has mass, is made up of matter, is made up of atoms, and the Earth has mass and also has atoms as well. So as a result of that, the Earth and you have this attractive force towards each other. The Earth has a huge gravitational pull, so what it does is it pulls you towards the Earth. Now, when we talk about weight, weight basically means, so weight is a force, and it's measured in newtons. And basically what weight is, it's the force of gravity acting on your mass. So for example, when you're on the Earth, because of the size of the Earth, because of the mass of the Earth, there's a force of gravity that's pulling you towards the Earth. And as a result of that, you have weight on the Earth. Okay, so you have a weight that's associated with you. So basically, because of the mass of the Earth and because the force of gravity from the Earth, it exerts a force on your body, and that's what weight is. So basically, weight is the force of gravity from the Earth pulling your body, which is made up of atoms, which has a mass, towards the Earth. So that's when we talk about weight. That's what we're talking about. Now, if you were to take yourself and you were to somehow able to get to the moon, and you were to stand on the moon, for example, your mass is the same. So your mass is going to be the same, but your weight is not going to be the same. You're going to be lighter. Okay, so in other words, there's not going to be as strong a force of gravity acting on your body. Why? Because if you look at the size of the Earth and the size of the moon, the Earth is much bigger. So therefore, the force of gravity from the Earth on your body is much greater than the force of gravity from the moon on your body. Why is that? Because the Earth has a bigger mass. Okay, it has a much bigger mass, whereas the moon has a much smaller mass. in comparison to the Earth. And then if we take the Earth in comparison to the Sun is so big and it has so much mass that the Sun actually is able to move the Earth around it. Okay, move the whole Earth. And how does it do that? Through this force of gravity. So basically, the way to kind of think about it is, as mass increases, gravity also increases as well. So that's what we're talking about when we're talking about the difference between mass and the difference between weight. So mass is measured in grams. Mass is a measure of how many atoms or how much matter the object has. Weight is a force, and weight is a measure of the force of gravity acting on the particular object. Okay, so when we're talking about weight, so it's if you're taking your weight on the Earth, it's the force of gravity from the Earth acting on your body, for example. So what we want to kind of start thinking about now then is the relationship between these two. So the relationship between mass and weight. So what kind of relationship is there between them? So what we can say is that if we can do an experiment to look at this as well. So if we we set up a graph. Okay, so we have our x variable and we have our y variable. So if we were to measure, for example, mass versus weight and look at the relationship between the two. So we can take a series of weights, for example, or a series of, for example, you can take an object that has a weight of, let's say, 10 newtons. You can take another object that has a weight of, let's say, 20 newtons, and so on and so forth. And what you can do is you can weigh them on a weighing scales. So something like that, okay? So you can put these on here like that, and you can get the weight, for example. You can get the weight in grams, or you can get the weight in kilograms, whichever, or you can convert from one to the other. And what you'll find is, so let's say if we plot a graph, so we will have the thing that we are weighing is the dependent variable. So for example, if we are, or the thing that we're measuring, so in this case we're measuring weight, so we're measuring mass, so we put mass down here. And then the independent variable is the thing that we are changing. Okay, so in this case we're going to be changing the weight. So weight in newtons. And we can measure the mass, for example, in let's say in kgs, kilograms. So what you'll find is that, so if you start off, let's say 10, 20, 40, 50, etc. and go on, and you measure the mass, what you'll find is that there's this graph that you'll get like this, okay? So this graph is like it's a proportional graph. Okay, so you're going from 0, let's say as you move across the x-axis from here to here, you're going from small to big. As you move up here along the weight in newtons scale, you're going from small to big. And what you notice is that as you increase the force, okay, or as you increase the weight, what happens is the mass gets bigger. So the more force or the more the weight increases, the more the mass gets bigger. Or another way to think about it is, as the mass increases, the weight or the force also gets bigger as well. Okay, so what you can see is there's a direct relationship between these two. So they're directly proportional to each other. So again, this is another, if you like, pattern or relationship that you can see between two naturally occurring or observable phenomena. Now, what's also really important as well is that that you're able to convert between weight and mass. And what you can do is we can use a formula. So we can use this formula here. So weight in newtons is equal to mass in kilograms multiplied by 10. So if we wanted to, let's say we wanted to find out if we have, let's say, 2 kilograms. So 2 kilograms. So that's the mass. So what's the weight of that? And what's the weight in Newton? So in newtons. Okay, so remember, weight is measured in newtons. It's a force. So what we can do is we can use this formula here. So we can say that the weight in newtons, okay, so this is what we're trying to find out. So weight in newtons is going to be equal to mass in kilograms, which in this case is 21, multiplied by, sorry, mass in kilograms, that's not 21, it's 2. So 2 multiplied by, multiplied by 10, which is going to be equal to 20. Okay, so it's going to be equal to 20 newtons. So 2 kg, 2 kilograms is equal to 20 newtons. So we can easily move back and forth. So if we have a particular weight, if we have a particular mass, we can find out what its weight is in newtons by using this formula here. Now, what's important is that that when you're using this formula, that you make sure that you convert your quantity into kilograms. So for example, if we were to say, okay, so what's 5,000? So the mass is 5,000 grams, and we want to work out what's its weight in newtons. The first thing what we have to do is we have to convert this into kilograms. So notice that this formula, it says in order to use it, the mass has to be in kilograms. So what we can do is we can convert this into kilograms. So 1 kilogram is equal to 1,000 grams. That's where this kilo part comes from. So therefore, if we have 5,000, so that's going to be that multiplied by 5, which will give us 5,000 grams. We'd have to multiply this by 5 then as well. So that will be equal to 5 kgs. So 5 kilograms is equal, so 5 kg is equal to 5,000 grams, or 5,000 grams is equal to 5 kg. So then we can use this formula. So its weight in newtons is going to be equal to its mass in kgs, which is 5 multiplied by 10, which is equal to 50 newtons. Okay, so we can say that 5,000 grams is equal to 50 newtons in weight, okay, or has a force of 50 newtons on the earth. So that is the relationship between mass and weight, and then how to convert from weight. It's how to convert mass into weight into newtons, and you can also use it to go the other way as well. Okay, so that's that. So just again, as I said, the learning outcome for this was students should be able to investigate patterns and relationships between physical objects. So again, this here shows the pattern and relationship between mass and weight. Okay, and it's an investigation that we carry out as well in the lab.